two, did we do the first two? Oh, good, okay. So since we did just the first two yesterday, we'll start with the third problem on practice test 2, which is, I need everybody's attention now, we're getting started. Luke, get your practice test out, we are practicing. Ichi, you want to get yours out too, so we get a really good grade this time?
Yeah.
Ready, Phil? Ready? No? Are you ready?
Yeah.
All right, here we go. We're going to write the equation of an ellipse with a center and all this other information. All right, now listen. Hopefully at this point you know what the equation of an ellipse looks like, but if you happen to forget, turn the page to a different page of the test, and in this practice test, it is question number 4. I give you an equation of an ellipse on the test, so if you forget what you're supposed to be looking for, look at question number 4. It's something squared over something plus something squared over something equal to 1. That's what I'm trying to do in question 1C. Write the equation of the ellipse. Now, it has a center at 2, 3. Does that help me at all in filling in the empty spots in my equation? Yes. If the center is at 2, 3, don't I have x minus 2 and y minus 3 in my parentheses? All right, now what else did they tell me? They told me that was my center, all right. They said a major axis, thank you, has a length of 12 and a minor axis has a length of 4 and it's stretched horizontally. Okay, now what does that mean, stretched horizontally? That means it has this shape, right? Now, the major axis, that would be this right here, has a length of 12. How does that help me if I know it has a length of 12? It went 6 this way and 6 this way, which means there's a 36 under the x. How do I know it's under the x? Because it's going xy's, right, horizontally. Now the minor axis has a length of 4. So that means the whole thing is 4, which means you're going up and down 2, which tells me what? There's a 4 under the y. And that's it. You're done. All right, so let's try the next one. It's another ellipse. So it's going to have the same kind of equation, right? So let's see what we know. This time we know that we have the endpoints of the major axis are at negative 2, 1, and negative 2, or negative 2, negative 7. And the minor axis is 0, negative 3, and negative 4, negative 3. Are you checking at the office, Cameron? You need to go do that real quick, okay, and then we'll review it. Thank you. So here we go. This is what they told me. That's what they told me. How am I going to get the numbers to fill in my equation? Here's my major axis, and here's my minor axis. Any ideas about that? Well, where they cross would be the center, right? Can we tell where they cross? Negative 2, negative 3. Is that okay with everybody? You can do that a couple ways. One is, the test is going to be on graph paper, so it's going to be real obvious where they cross, so you can just look at that. You could also do midpoint. You know that the center is in the middle of these, so if you want to find the average, you can. So what is knowing the center? How does that help me, knowing the center? That means I can do my numerators, right? So what would this be? X plus 2 and y plus 3. Well, what happens if you accidentally put y first? Nothing. I don't care. We usually put x first in an ellipse, but since that's an addition, you can do it in either order, so don't get hung up about that. Just put the 2 with x and the 3 with the y. All right? Now, what about the denominators? Well, how far up and down am I going? You'll have to do some counting there. Going up and down 4. So that means there's going to be a 16. And where's that 16 going to go?
Y.
Under the y. Now, I'm going to go sideways. How many? 2. And if I go sideways 2, then underneath the x is a 4. And there we are. Anybody have a question about the ellipse equation? Okay, the next two, we just go in order. The next two, E and F, are hyperbolas. They have exactly the same format as the ellipse, except there's a minus in there, right? So here we go. Problem E. Thank you. We're on practice test 2. Problem E says the center is at 2, 4. It opens horizontally. Now that means the ellipse has, or excuse me, the hyperbola has that shape. It opens sideways, horizontally. What does that tell me, by the way, about my equation? If I'm opening sideways, what do I know about my numerators? X is first. So it's going to be X minus Y. Because remember, in a hyperbola, the way it opens is the letter that comes first. Now we know our center, so I'm going to go ahead and fill that in. All right, so what do I know? The transverse axis is 10. Now what's the transverse axis again? The one that joins the vertices. That's the transverse axis. The one that connects the hyperbolas. If that is 10, whoops, almost gave it away there. If that is 10, what does that mean about the number under X? 25. Remember, if that's 10, that means you're going back and forth 5. So 5 squared is the number that goes here. Now the conjugate axis, which is the other one, the one that just, you would build the box around, that other axis is 6 units long, which means we're going up and down 3, which means under Y we have a 9. Everybody okay? Now F is another hyperbola, so we're going to do about the same thing. So we start with the format, so we can just plug in numbers. Remember, it's a hyperbola, so there's a minus there. All right, so the endpoints of the transverse axis. Now remember, the transverse axis is the one that connects the hyperbola. So we have a 2, 3, and a 2, negative 5. Now, if this connects the hyperbola, then the hyperbola must look like this, right? Would you agree with me? Transverse joins the vertices, connects the branches of the hyperbola. The endpoints of the conjugate axis are 0, negative 1, and 4, negative 1. So this is the other axis. What information does that give me, Ethan? Okay, this is a hyperbola, and a hyperbola actually does have two directrices, but we didn't talk about them. What do I need to know to fill in the numbers in that? To fill in all of these numbers in here? I need to know the center. Can I get the center out of this?
Yeah.
Is there a reason you have a mustache? I know, and did you get a note from Mrs. Somp saying you had permission to do that? Okay, well, I'll put a detention in. And if she says it's okay for you to grow it out for prom, then she can take it out, or Mr. Davis will take it out. Okay, do you know how to find the center?
No.
Yes, you do.
No, I don't.
It's drawn on the board.
I don't know how to do it.
Can someone help Ethan? Can we figure out what the center is from what we have up here? What? 2, -1. Phil, would you tell him how you figured that out? Right there's the center, where the two axes cross. Would you tell him how you figured that out? There's a couple different ways. Where they cross, yeah. So if we, it's a little harder here, but if we were on graph paper, it'd be real obvious, right? Where they crossed. Here, you kind of see it on my grid. That would be 2, -1 where they cross. You could also do midpoint if you want to find the average of these 2 points. That would absolutely work. Now, be real careful, because you're tempted to put 2, -1 into your problem. But what do you notice about this hyperbola? Which way does it open? Up and down, which means what about my equation? Y is first. So you have to pay attention to your picture in a hyperbola. It matters what comes first in a hyperbola. So Y comes first, which means it gets paired with the Y number of the center. And there we go. Now, what about the denominators? Well, we can figure that out, because if this is my center, how far up and down am I going? 4? What does that tell me? That I'm going up and down 4. There's a 16 somewhere. Where's the 16? Under the Y, because you're going up and down 4. How far over am I going? 2, which means this must be a 4. There we go. We're done. All right, you okay with the hyperbola equation? All right, the next two are the parabola. Now, again, if you forget what the framework is, take a look at question 3. Question 3 is a parabola. So you can tell from question 3 that the format is this. If you forget it, let the test help you. Look at the other question about a parabola, and it will have the equation for you. So now we just need to fill in stuff. What do we know? We have a vertex at 6, -1. And we have a focus at -4, -1. Wow. Okay, so this is my vertex, and this is my focus. Now you need to know enough about a parabola to determine what this shape looks like. Parabolas, remember, open either up, down, left, or right. If that's the vertex and that's the focus, which way does this one open? Left. That's right, Megan. Because it's got to come around, it's got to enclose its focus. The focus is inside the curve. Now, what does it mean when it opens left? Well, this number is going to be negative. And which letter is squared? If you're opening sideways, it's going to be a y squared. So this is an x and this is a y. Now, can I fill in my parentheses now? Yep, because what goes in there is the vertex. So that's going to be x minus 6y plus 1. Now, the only thing missing is that number. Do you remember that that number is always 4 p's? And what's p? P is this distance. It's big this time. It's not usually that big. That's a big distance. What is that distance? 10. So if P is 10, then 4P will be 40. And there's a picture of your parabola, or an equation of your parabola. Yes. Please hurry. Now we're going to do another parabola. So our format will be the same.
You have to have your 4p in the equation.
Yes. No. That, I just put that there because I want you to remember that's how you find that number. That's not part of the equation. Okay, that's just how you find it. All right, so what do we know here? We have a focus at 1, 5. And we have a directrix at x equals 3. Now be careful. This is the focus, and this is the directrix. Any ideas on that parabola? What's it look like? It opens to the left again. Indeed it does, because it has to wrap around its focus, right? Which means, again, it's to the left, so that number will be negative. Left is negative. And the y is the one that is squared. If it opens up or down, x is squared. Any ideas on what the vertex might be? What? Yeah, 2, 5. Why is it 2, 5? Because it's right in the middle of the focus and the directrix. Remember when you find the focus and the directrix, you go the same distance both ways? So doesn't that mean the vertex has to be right in the middle? Which is 2, 5. So we got the 2 with the x and the 5 with the y. Good job. Now the only thing missing is this number, which is 4 p's. What is p in this problem? It's much smaller. This is p right here. What is p this time? P is 1, which means the number that goes in the equation is 4. Because in the equation goes 4p. All right, we only have 4 more problems to go. These are the ones like you had on your quiz the other day. All right, so here we are. We're going to find the center and the radius of the circle. Do you remember how to do this? What do I need to do? I'm going to complete the square, so I need to get my x's and my y's together. And I'll leave some blanks in there because I'm going to be adding something in order to complete the square. All right, what do I add here? Phil, can you figure it out?
Uh, 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus 25 plus 26 plus 27 plus 28 plus 29 plus 30 plus 31 plus 32 plus 33 plus 34 plus 35 plus 36 plus 37 plus 38 plus 39 plus 40 plus 41 plus 42 plus 43 plus 44 plus 45 plus 46 plus 47 plus 48 plus 49 plus 50 plus 51 plus 52 plus 53 plus 54 plus 55 plus 56 plus 57 plus 58 plus 59 plus 60 plus 61 plus 62 plus 63 plus 64 plus 65 plus 66 plus 67 plus 68 plus 69 plus 70 plus 71 plus 72 plus 73 plus 74 plus 75 plus 76 plus 77 plus 78 plus 79 plus 80 plus 81 plus 82 plus 83 plus 84 plus 85 plus 86 plus 87 plus 88 plus 89 plus 90 plus 91 plus 92 plus 93 plus 94 plus 95 plus
So 4, that's exactly right. That's what I'm gonna be adding, 4 to both sides. All right, Kean, what am I gonna add here? 9. Half of 6 is 3, squared is 9, very good. So this makes x minus 2 squared. Everybody good with x minus 2? Remember, it's a sign. Plus y plus 3 squared, and it adds up to 14. So nothing fancy here, we just want the center and the radius. What's our center? 2, negative 3. What's our radius? Root 14, done. Tony, you gonna get that one right, you think? Got that? All right, now we've got our parabola. So we're kind of going backwards to what we just did here. I'm going to give you the equation. So the equation we have is this. Now that's a parabola. Where is its vertex? You can always tell its vertex from the equation. Negative 3, negative 1. Now you do need to be careful and get that in the right order. It's always x comma y, so it's negative 3, negative 1. And you need the focal width. You can always tell that from the equation. The focal width is 8, always positive. Even if it's negative in the equation, it's positive, right? Now, here comes the tricky part. We're standing around out there. Which way does it open? It opens, watch it, what's squared? X. And if x is squared, we're going to open up or down. Since it's a positive number, we're going to open up. Now the focus is in here somewhere, and the directrix is down here somewhere. Does that make sense to you? You can figure those out if you know one piece of information. How far up do I go? I need to know that. We call that P. You guys are saying 4P is 8, so P is 2. So you're going to start right here and go straight up 2 units. So where will we be if we go straight up 2 units? 3, 1. And how about if we go down 3 units? Or 2 units, I mean, shoot. We come down 2, we'd be at, oh, thanks. If I come down 2, I'd be at negative 3. And some of you are going to say you'd be at negative 3, negative 3. That's the correct point. But your directrix is the line where we cross the y-axis at negative 3. That's my directrix. So here's my focus, and here's my directrix. Anybody have a question about that? All right, now we've got our ellipse. So it's already in good shape for us. All we have to do is figure out everything. All right, where's the center? Easy points. Where's the center? 2, negative 1. And now I'm going to put my vertices on. That's the V, vertices. So the 4 tells me I'm going to go sideways 2. Oh, sideways 2. So I'd be at 0, negative 1, and 4, negative 1. And up 3. So that's 2, 2, and 2, negative 4. So here's my shape. There we go. So there's my center. These 4 points are the vertices. So how did I get the vertices? By simply counting sideways and up and down. This number tells me sideways. Square root of 4 is 2. Up and down 3. This would be the major axis, right? It's the long one. It's 6 units long because I went up and down 3. This one is the minor axis. It's 4 units long because I went sideways 2. The only thing left are the foci. I don't know what they are. You don't know what they are maybe, but you can get half credit by just paying attention. What do you know about every point on this line right here? X is 2. So there's half. Now the rest of it's a little harder. You have to remember that to find the distance from the center to the focus, we subtract our denominators. You do the opposite of what this says. It's 9 minus 4. So that's root 5. We're going to start right here at the center. And I'm going to go up root 5. So what would that y coordinate be? If I started at the center and went up root 5, what would that be? Negative 1 plus root 5 and negative 1 minus root 5. Any question about that?
There's always the bigger number minus the small.
Always.
Like regardless of
Yep, it doesn't matter.
under X.
Yep. It's always the big one minus the little one. If you try to do it the other way, Phil, you'd get a negative number, and then when you took the square root, it would be imaginary. Right? You have an I, which would do that. So just big minus little. So it stays positive. All right, you have one more to go. This is the big one. This one's worth a lot of points because it has so many parts. But let's get filled out the easy parts first. All right, so here come the easy parts. Where is my center? Luke, where's the center?
Center.
It is.
Yeah.
2, negative 3. And you even got that in the right order. Did everybody else? Even though the equation is backwards, when you find that point, you always put the x first. So 2, negative 3. Good. Where do I go from here? I start at my center and I start counting out the bow, right? Just like I did with the ellipse. So what's this 9 tell me to do? Watch it, it's under y, so it's going up and down 3. And under x, I'm going sideways 2. Now normally, if it's an ellipse, I would make an oval, but I'm not gonna. I'm gonna make a box. Right? Here come my diagonals. Okay, here comes the moment of truth. Which way does this guy open? Do I draw my hyperbola in the up and down parts or in the sideways parts? Up and down. And I know that because y comes first. Now, when I draw my hyperbola, I come right here to the edge of the box, that point right there, and that becomes my vertex, right there on the box. That point on the box is your vertex. So over to the side where it says, what are the vertices? It's those 2 points. How did I get them? I didn't label them. So I'm going to figure it out again. How did I get them? I started here at the center, and what did I do? I went up 3, so that's 2 comma 0, and then I went down 3, so it's 2 comma negative 6. Again, you're going to be on graph paper, so you're just counting. This axis right here that joins the 2 pieces of the hyperbola is the transverse. So your transverse axis has a length of what? 6. The other axis is called the conjugate axis, and it has a length of 4. The foci are inside the hyperbola, right? So they're going to be here and here. And just like with the ellipse, half credit, easy. What do you know about these 2 red points? The x has to be 2. Now to find the y, it's a little bit harder. You need to remember the rule. The center to the focus in a hyperbola, you add them. So it'd be the square root of 13. Remember, in an ellipse, you subtract them. So you're going to start right here at this point, and you're going to go up and down root 13. So what will this y be right here, this y coordinate here? What will it be? I'm going to start at negative 3 and go up root 13. Start at negative 3 and go down root 13. Now sometimes when we do this, we get a whole number and not a radical, right? So we just go up and down that whole number. So you'd start here and go up 5 and down 5. Whatever that amount is, that's how far you're moving from your center. Now the only thing left, I think, is the asymptote.
Do you have 4 vertices of just
Not on a hyperbola. You have 4 on an ellipse, because when you make the shape, you join them all. But the hyperbola is the green thing. How many vertices does it have? Just 2. These are not vertices. They're not even on the green thing. I use them to build the box, but they're not part of the curve itself. All right, now I need asymptotes. The asymptotes are lines. So I start with my framework, y equals mx plus b. And there's 2 of them, so I'm going to have to do this twice. But the good news is, once I find the slope of 1, I know the other one will just be the negative of that. So, what is the slope? Think about this picture. Rise over run. How far up did we go? 3. How far over did we go? 2. So my slope is going to be 3 halves or negative 3 halves. Up 3 over 2. That's what I'm putting in for the m. Now, what am I putting in for the y and the x? What do I always put in for the y and the x? The center. That's where those asymptotes cross. That's the center. So y is negative 3 and x is 2. For both of them, y is negative 3 and x is 2. Oh, this is an easy one. Because when I multiply, that's 2 over 1. I'm going to go straight across, so that's going to be what? 6 over 2, which is just 3. So b equals negative 6. So your line is y equals m x plus b. So there's one of your equations. The other one, same thing's going to happen. This is going to be negative 6 over 2, which is negative 3. You're going to have a calculator. I don't think you can do it with this one, but you'll have a calculator to use to help you with this. So this line is negative 3/2 x plus 0. Is that okay with everybody? 3/2 is the slope, and it came from how I built the box. I went up 3 and over 2, because that's how we got this line. If you started, you know, here, if you went from here to here, you'd go up 3 and over 2. All right, we have time to do 1 or 2 more problems. So of all those, that's what's on the test. So of all that, which would you like to practice another one of?
The circle within, like the one that you have to do.
All right, let's do one where I give you the end points of the diameter of a circle. So you have to write the equation of a circle, and you are given the end points of a diameter, and let's say they're negative 210 and let's say 618. Okay, so there are the end points of the diameter, and your job is to write the equation of the circle. So you know that a circle looks like this. Circles are the ones that you have to do the completing the square for. And isn't that the kind of equation you always end up with when you do that? So you have basically 3 numbers to fill in. What are these numbers? Where do they come from? These 2. Where do I get those? Those are the,
Radius.
no, this isn't the radius.
Diameter.
No,
Center.
that's the center. These are the center of the circle. Remember, Phil, when you have an equation like
Yeah, but wouldn't, wouldn't.
x minus 2 squared, y plus 3 squared equals 9, your center would be at 2, negative 3. So we gotta find the center. I don't know what the center is. I have to figure it out. What do I know about it? It's the midpoint of the diameter, and midpoint is average. So what is the average of negative 2 and 6? 2. To find average, I shouldn't have to be telling you this. You add them and divide by 2. So negative 2 plus 6 is 4. Divided by 2 is 2. What's the average of 10 and 18? 14. So my center is 2 comma 14. X minus 2, y minus 14. So that takes care of those blanks. That's the midpoint of the diameter. Now, what goes here in the equation? Just in general, what do I put there? That's the radius squared. That's going to be r squared. So if that number is a 9, you know the radius is 3. Well, isn't this the radius? So I need to figure out the distance between here and here. And the distance formula is 6 minus 2 squared.
Teachers, please pardon this interruption. This is a brief announcement about the expectations during Flex today. All seniors are to report to the cafeteria for Flex. This is not optional. Even if they have completed the survey, all seniors should still report to the cafeteria during Flex. Also, at 9:45, we will have a football leadership meeting in the auxiliary gym. So at 9:45, all the football leadership attendees should go to the auxiliary gym. Thank you.
Really pack up.
Okay, so distance formula says x minus x squared, y minus y squared. That's 4 squared 16, that's 4 squared 16. So the radius is the square root of 32, but when I write my equation, it's x squared, y squared, r squared. So that number is actually 32.
Okay.
All right, I know, this should be an easy test if you've been paying attention. Ellen, you turn off the video. Okay, now you have flex.